I know you are really tired, you know, a long day today. I try to not annoy you, don't bother you too much, but it can happen. So sorry in advance. So yeah, who I am? I am the guy. I am a postdoc at the University of Bologna, and my research topics are not really related with Scala, but I use Scala since 2016, and I like most things related with reinforcement learning in these years, and also with large-scale distributed system. At the end of the talk, I will give you an overview of how I use Scala in this kind of system, but the core part of this presentation will be the central part. Oh, I do. How can I? This one? Ah, this part here, in which I show you how I use Scala in the machine learning ecosystem, leveraging ScalaPy. How many of you know ScalaPy? One. Oh, this is fun. Two. Ah, because I said two. Another question. How many of you never used machine learning in something, you know? Okay. You use which kind of language or ecosystem? Python? Python? Oh, this is really interesting then. And so this is the agenda of the talk. In the first part, I just give you some perspective of how we use Scala in teaching in the university. How many of you study Scala at the university? Okay, this is interesting. And then yes, the last part would be just, you know, I will go into the hyperspace just to present something that I really love, but okay, this is not really the core of the presentation. So, teaching. What we do in the University of Bologna, in particular in Cesena, we mainly, at the master, because, you know, at master we are more easy, we don't want to kill people. We present two courses that are, two main courses that are, one is called Programming and Development Paradigms, and the other one is Concurrent and Distributed Programming. In these two courses, we use Scala in like 6 years, and we train 600 students. So, how many of you from Cesena? No one. So this is not good. we made some mistake, perhaps. We have to improve. But what is the point here? You know, it makes sense to use Scala in these two courses. Why? First of all, obviously about libraries. In Scala, we have a lot of libraries that, you know, in particular in the concurrent side of the part, in which we have Akka, for instance, that is really interesting in the perspective of teaching, you know, because this is a paradigm, and we like the actor model, we want to, you know, teach this kind of model, and we have a library that is kind of easy, Akka, and then we use that. But other stuff that we are interested in particular in the paradigm stuff, we are focusing this kind of stuff on the abstraction gap. Why? Because Scala, and I will present here, you know, you never think what is programming at the end. It's something that we translate our problem space, you know, our problem like a video game, in a solution space. So we use a language. This gap change in about the language that we choose. For instance, if we choose C, you know, this gap is really large, you know. If you use Java, it's smaller. If we use Scala, it's, you know, smaller. But not only that. To close this gap in a programming language, we can do two things mainly, no? We can use library or write library. This close the gap. So for instance, in C, there are engines that help us to write games, no? But not only that, also domain-specific language, okay? And Scala, with these three steps are the most idiomatic. For instance, Scala is, I think, one of the best languages to create the domain-specific language. I don't know if you agree with me. How many of you ever try to write a domain-specific language in Scala? Not that many. I think that most people did that. How do you feel like when you write a domain-specific language? You like it? It's like a pleasure thing. Yeah.
Worse than Lisp.
Yeah. Oh my God! Please kill me, God. No, I'm joking. So.
It's better than Natural.
I mean, it depends. It's another way to write a domain-specific language. It's not, by the way, I don't want to. Okay. And which kind of library we use mainly in these courses? Akka, obviously, for the concurrent paradigm. Spark to an example of declarativity, and for, you know, the fact that give you a domain-specific language that is really high level, no? Because it helps us to write, you know, code that manage big data, and you you don't have the feeling to do that, because you just use stream, high level, at least high level. And then obviously we also use Scala test because it helps us to, how many of you never used test-driven development? Never. Oh, you know what is it? You know what is it? Test-driven? As a ADD? Okay. Okay. If you don't know this, you don't know this. How many of you know this? Test-driven development. Okay. Okay. So this one is another paradigm to write tests and stuff. But we use Scala test because it helps us, even if it's a shit as a framework. I know that it's really monolithic. You have a lot of stuff, but it helps us to have different style in testing. It is important, these kind of approaches. So it has its value when we teach. And at the end, today I saw a lot of talk about Scala native and Scala.js. We introduce also this library in a perspective of creating a language that is multi-platform. And this is the main library. Obviously, I try to bring more cats effort and cat stuff in the courses, but my professor still not like that much. I'm sorry. I try. I do my best. But this is what I can do. So this is just a little overview of how we use Scala in our university and why we think it's important, mainly for this reason. This is the main reason in which Scala is really important, obviously. And okay, now, machine learning. So, only 3 of you program something related with machine learning, right? Only 3? And in Python. Which library do you use? TensorFlow? Scikit-learn, okay. TensorFlow? Okay. This is kind of, okay. So, I'll try to give you just, before an overview, do you know what is machine learning, by the way? Yes. Everyone, more or less. Not the idea you have data or you have a simulation, you have a model that you want to improve it through a feedback, no? You know what is reinforcement learning? Some of you. You need to study, guys. I'm joking. So, in general, machine learning toolchain is composed by 3 main parts. There is a part of data visualization that is really important because you need to understand the data that you use, no? Then there is a learning framework like Scikit-learn, TensorFlow, PyTorch, something like this. And then you have data visualization. Okay, these are the 3 main parts that you need to write machine learning code, at least. Okay? So, and the process of, development, I try to reduce at minimal. It's really harder to do that. But, just to give an overview, you have a first phase in which you explore the data to understand the features, how you can use it to improve your model. Then there is a phase of data preparation. Consider you want to create an agent that plays video games, like Mario, okay? You explore the data, in this case, okay, our framework. But then the agent needs another kind of input to process that information. So in general, there is a phase in which after you explore the data, you prepare for the model. Then there is the model definition. You can create, a neural network. You can create transformers. Transformers, like GPT stuff. You know that. Then there is the learning process in which, you perform a epoch in which you try to improve your model. At the end, you deploy it. This is the main pipeline. So when we choose a language, we need a library that covers the whole pipeline and the whole toolchain, no? This is what we want to do. When I started my PhD, I had a problem. I need to integrate the machine learning toolchain in our solution that was Java-based. So my professor said to me, okay, start to look at what we have in Java. Okay. And then I do this little overview in my 3 years ago. Now this thing has changed. I know that yesterday, for instance, a new library that is going to be really promising is development in Scala. So who knows? Perhaps the deep learning in Scala will be easy to do. But at the moment, Scala, we had a lot of libraries that has, good idea like magic, very good, but none of them are maintained. So no good. But in Java instead, there are several solutions. Moreover, in Kotlin, you know Kotlin as a language? Okay? Who says sadly? You? No, it's not that bad. Come on. Java is worse, no? What do you prefer? More or less. Yeah. And nowadays in Kotlin, there are a lot of effort to produce a similar pipeline that has Python in Kotlin. And so we can have in some years perhaps something that is usable in JVM. But after my first exploration, what I observed that I cannot use both Java and Scala because at the time I want to perform something like reinforcement learning. In both of the ecosystem, there are no libraries. So I was stuck. How can I do that? At the end, I found a way that is Python oriented. And I show you what does it mean. So this is just, but if so nobody know none of them, right? It was just to understand, you know, smile? No? Different? No? Interesting. No. Okay. If, you know, in a moment of your life you want to do machine learning in Java, you have my slide, you can start from there. Okay? In Scala, yeah, I just make pointer because there are, for instance, this one is like one of my favorite because it performs machine learning based on type classes and immutable data. Was kind of, wow, it's wonderful. No one implements anything, so that. This one, sorry guys, but it was really hard for me in that moment. But this one is a new one, and it seems to be supported, and is a Scala version of PyTorch. Who knows? We will see. In 1 year, we will see if we will maintain. Here, I just write also like a mini list of other libraries if you wanted to say something. But you know, as I said, no, I don't suggest you to use it. Okay, it is better perhaps to start from here, find something. You can write also a domain-specific language on top of that, and instead of using this was not kind of nice, but it's that, by the way. So we have a lot of pitfall, as I said before, because, okay, my goal was to use reinforcement learning, there isn't. Then there is another problem. Since I made the research, I tried to use the state-of-the-art model in deep learning and stuff. Unfortunately, in Java, we don't have it. Like, you know graph neural networks? No. By the way, it's a kind of, you know convolution neural network? Yeah, you know it. It's a kind of neural network. No? There is advanced neural networks that are called graph neural networks that process graph directly, not images. In my research, I need to use that. No. Then we had another problem. We have several libraries that cannot speak with each other because there is no common space, common design space, as in Python. So, you know, if you want to use something new, it's like a nightmare to integrate. And then, as I said, Scala has a lot of good ideas, but you know, no solution can be used in practice. So, I try to go towards what I call Python-oriented solution, in which we need mainly 3 components. No? We need some kind of interactivity. Some of you never use notebook style Jupyter. You know what is Jupyter? Okay, you know that exists Almond? Oh, no? Okay, you know Jupyter is a way to write code, I would say, no? In which you mix Markdown with code. An angel writes this library that is called Almond. That is a kernel for Jupyter, in which you can write Scala code directly on the Jupyter. This is kind of important when you do data science stuff, because in the first phase of data exploration, you need something that is really easy to share with the other people and kind of interactive, because there is a lot of trial and error. So this helped me to write something like this. Then I need Python bindings to use the state-of-the-art libraries. To do that, there is this library that is not that maintained, but still it works currently, that is called ScalaPy. That, who knows, you know, so only one. Okay, and then, yeah, what is the idea of doing this? We still want to have a pure solution. We don't want to have shit. So the idea is to apply like an onions architecture, no? So in which the core is still Scala, pure Scala, good Scala functional code. And at the end, we in some way encode this binding. This is what I've done in my research. So this is the overview. Now I will just present the practical stuff. This is Almond, as I said, is a kernel for Jupyter, and it's based on Ammonite. How many of you ever use Ammonite? A lot. You like Ammonite? No? Why not?
Because we have scala-italy.
It makes sense. It's okay. Sorry. Yeah, for Jupyter, it's kind of nice, Ammonite, because it really helps to import code. And what adds Almond to Ammonite? It adds the possibility to output data like this: images, HTML. That is this one. You see, this is an HTML table, and so on and so forth. In particular, this is Scala code. Even if it's quite small, right? Yes, it's kind of invisible. Sorry, guys, I wish you after some code. And after that, okay, Almond use Scala, pure Scala, not Python. Okay, if you want to use Python, then you need to use ScalaPy. What is ScalaPy? It's just a library that is inspired from what Scala.js does. So writing facade against, JavaScript code. It helps you to access to Python ecosystem. Differently from Scala.js, we have both the world. So when we run an application that is based on ScalaPy, we have both the JVM and the Python interpreter that work together. So it's kind of different, the design space of this solution. What it does provide? We can create static typing to the Python ecosystem. Something like what we do with Scala, with Scala.js. Then we can also have near native performance because we can compile our code in Scala native. So we can use CPython. You know CPython? Yes, it's the... Okay, we have the full access to the Python ecosystem. Okay, now I have some demo about how to use this. Here there is the GitHub repository. So if you want to use Jupyter, Scala, and ScalaPy all together, you can start from there. I also prepare a Docker image for the engine, but it's not that hard. By the way, you see something here? Yes, okay. Okay, it works. So these are some page that you can visit if you want to have more details about ScalaPy and how to write facade. This is also one of mine, but nothing special. No, please, God, why? This doesn't work anymore. Okay. By the way, this is a Jupyter notebook. If you use Rise, that is a Python library, you can transform Jupyter notebook to presentation. I love that. So sometimes, by the way. Okay. How to import ScalaPy to your application? You have to include this dependency. And obviously. Now, okay. And it's important. So, ScalaPy, as I said, is like a bridge between JVM and Python. Currently, it supports only Python version 3.6 and 3.10. And how it works internally? It means use Scala dynamic. I don't know if you are familiar with this kind of stuff. It's the way in which Scala can interoperate with unsafe part, I would say. And also, it uses some macro to improve the performance of the facade. These are the main concepts. There aren't that many. Mainly, the most important is 5, I would say. PyN is like the root type of Python, and is like 1 because Python has only one type. But if you access to Python, you don't have the possibility to use PyDynamic, so you cannot call in unsafe code. You can always convert PyN to PyDynamic because it is supported. But in general, it is when you use the safe part, you should don't do that, only inside the facade. Then there is the Py module, that is what we import in general in Python library. When you write import TensorFlow as, this is how you import code in Scala. Then we have PyGlobal, that is like the global space of Python that is accessible from ScalaPy. And then this is the most important part, that are two type classes that are writer and reader, that are the one used to convert Scala object to Python object and vice versa. Okay, now I just want to give you a little taste of what does it mean to use ScalaPy. So, first of all, you have to import the, the entry point, that is this one. Shadj is the guy that implements this library. And then how we can access to Python part, like this. This is the unsafe part, okay? Okay, this part is used to access to the global ecosystem of Python. Then you can call each function. This is unsafe, completely unsafe, because I can write like this, but also like this. No problem, because, who cares? Python, lovely language. By the way, sorry, I hate Python a lot because, I need to work with that. When we have to handle with lists and stuff like this, we have also this special kind of package that is called sequence converter that are used to have optimized access to list, because as I said, we have two engines here, no? So when we have EV object, sometimes we don't have to have a copy of them, but like a proxy, no? That an object live like in JVM and Python just access to that. Other time we need to have copy. So in this kind of scenario, we need to use Python sequence converter. No, it's not. It stopped to work. And how we can, convert list, Scala list, or in general sequence from Scala to Python in this way? We have to create our list, and then we have to call this method to Python copy. This, what it does, it create another list in the Python ecosystem with that elements. Okay. Yeah, this is when we, as I said, each Py dynamic can be converted, each Py any can be converted to Py dynamic, and then we have all the unsafe code to be used. As I said, this is a copy. Bracket update. What does it? What it does? Oh my damn! Please. What it does is it updates the first position of the list. As I said, this is a copy. So you see, this is the list in Python. This is the list in Scala, obviously, because it's immutable. We want to maintain the good part of Scala, no? Okay. As I said, we also have the proxy. What does it mean? That when we create a list, in this case I'm mutable because I want to show you that if I change something in Java, it's also changing in Python. Okay, this is the list 1, 2, 3. I create a proxy, then update the list in Scala, put 100 in 0, and then here access to the list in Python. As I say, it's also updated with 100. So this is kind of low level. Sorry, guys, just to give you the perspective of the shit that you have to handle when you use ScalaPy. It's not that they have some troubles, but by the way, it is the only way that I had to use reinforcement learning. So here I am. Okay, the good part of this whole trip is the facade. Indeed, we can create facade on top of unsafe code in this way, like blinking, where you have to use a special tag that is @py.native, and then here you can write the safe code, with right typings. Like in this case, the PyString has this method that is called count that accepts a string and return an int. Then with PyNative, it internally uses a macro that write the right code here. So it use the underline object, and internally it uses the reader to convert the Python object to the Scala 1. And how we can use that? You need to cast it. So because when you create something in Python, you don't know the type, but you can use has, and it converts to the right typing, and then you can use count. Obviously, here, if I pass 1, let me execute this. Compile error. Even if it's not visible, there is a compile error here, okay? Okay. Okay, interesting. Nice. You can also create a facade with generics in it. Obviously, then, if you have to pass, this generic, you have to pass also the reader and writer each time, because otherwise, ScalaPy cannot convert the value, from Python, in this case, to Scala from Python. This is an example of creating a safe list in Python. And perhaps it works. Yes. Uh-oh. Wait a minute. This should not be. Yes, sorry. There is something that I don't. Okay. I come back. Yes. Okay. This is another way to access to Python ecosystem. This is like PyQuote, in which you can write Python code directly there, and is interpreted by the Python machine. And what we do here, we create a list of numbers, and then we convert it as a safe Python list of integer. So even if it's a mutable, so we can update the position of index 0. We cannot do this. That in Python is legal, no? Because Python does not have types, so we can also put 10. With this facade, we restrict the possibility of the underline as list. With the idea now that we want to have safe typings, no? Okay, this is an overview. How we can use this facade to perform something like machine learning in Python. I just have another example. That is this one. But if nobody, pandas? Pandas, you know it. Okay, matplotlib? Okay. So here just an exploration of how can I use ScalaPy to have the similar experience of Python in Scala, so with nicety of Scala, so with having typings. Okay, first of all, these are utils to write facade. Okay. No. What happened? Let me see. Check. Okay. Sorry. Okay. Starting from here. Okay. What we have to do, considering this is the part that perhaps you do in advance. So you implement your own facade. Here, just a little example of implementing some part of that I used in the part of the next part. But this could be the whole library. Okay. How we can do that? You have to write. Sometimes you can use directly PyNative as before, but other time you need to have some workaround. Like in this case, show in matplotlib produce a side effect, but here I want to have a result. I want to have the picture. So this, for instance, the code that I used for getting this side effect and putting in a picture. The other part is a way to using the underlying object, but changing the name of the method. Now, sometimes I want to have my name that follow my style, because in Scala, for instance, they use the underscore. I don't like it, no? So this is a way to change it. Okay. Then this, for instance, is wait a minute. Perhaps I lose something here. Okay. This, for instance, is the facade for pandas. these are, you know more or less what is a pandas data frame. Is this like a collection in which we have columns, and for each rows you have an element of the, the data. Here I implement some of the, the methods. As you say, sometimes you can use directly by native. Other time you can change a little bit the, sorry. Sometimes you can change the name, like here. I don't want to write the code like sort values. I want to call it like this. So you can change the name. And you can also use overloading, like here, because sometimes, you just call like this, other time you call like this, and so on and so forth. Here, for instance, I also create like enumeration, because Python does not have an enumeration, but sometimes you pass like kind, and you say, okay, I want to plot this, and I want that is aligned. I don't want to write string because it's unsafe. So I create my enumeration with, the operation that I support, and then here I can pass them. Okay. Okay, I execute this. This then is like the typing for the modules. In this case, pandas give us both rich CSV, that is a way to load a file from CSV in pandas, and also plotting, that is a way to plot data frames. So I load both of them. And then I just to demonstrate to you how you can use these little facets to explore data as you can do in Python. So for instance, I can read my CSV and remove some columns that I don't want to use. And then I want to get the first 5 rows. This is the full data frame, and this is the rows that I plot here. Since Salmon support HTML, I can also pre-reprint that in this way, producing the HTML from the data frame. Yeah, okay. Obviously, this is type safe now, so I cannot write this. This is the good part of the sheet, But you see the feeling of using Scala like this. You feel like a language of scripting, no? Well, with the good part that is type safe, so you catch the error in advance. Okay. So obviously you can also access to the single column. In Python is a code like this. I don't know if you don't say. And you can also like plot stuff. So in this case, I want to, this data set report the happiness score of the country, something like this. And the happiest country is like in the north of Europe, like Denmark, something, I don't know, some there. But yeah, what I've done, I would say if happiness depends on freedom. So I sort the value by freedom, and then I verify, the country and happiness score. I take the first 5 and I plot this with box. You see, like Python. You see, it's not really related with freedom, because we have Uzbekistan that has a high freedom but not that high happiness score. I don't know which country is it. But a city that has a good freedom, but is a shit. People are really sad here. The other one is Norway, Denmark, super happy people, like they like to go. I don't know what they do in these kind of places, but they are happy, so they need to understand. Okay, then we can also do another kind of plotting. This is the same of before, but I sort by the GDP, that is, the money, and you see, money is like related with happiness more than freedom. Who knows? Makes sense. At the end, we can also use more kind of complex plotting stuff. No. Yes. This is like a scatter matrix. I don't know if you know what is it. But in this case, in this way, you can understand if a factor influences the other factor. So for instance, if we take happiness and we go like this, we see that with high GDP, we have an high happiness score, so it's something related, and so yeah. Just this data science. this is how we can build, facade with ScalaPy. You like it? Or you're like, not that much? Okay.
You should try with programming languages.
So?
Happiness with programming languages.
Python is like the worst one, I think. Wow, really bad time with Python, guys. Okay, this is just the technical part of the presentation. So if you wanted to, if you happen to you that you want to use Helm on ScalaPy and Python, you can start from my repository and make experiments. Now, just 10 minutes to this. 10 minutes is okay. Okay. To show my real interest in research, that is, I don't know. No, I'm joking. No, from start. Okay. That is like drumming. Sorry, there is no meme, no image. My bad. What I'm doing? Swarm robotics. You know what is swarm robotics? Oh no, there should be videos here. By the way, you know what is it? No? Oh, allora, just a video. This, if it works. No, at all. Okay, this one is my favorite. I love it. Please start. By the way, why you are so? No, you are a bastard. From current slide, perhaps. Oh, no. It's not the day. I just go direct to YouTube. Sorry, guys, but swarm robotics. What is the name of this? Oh, this one. Okay, so I go to the. Oh, you see? Look. You never saw such kind of video? No. Oh, look, it's beautiful. Stupid elements that form collective structure. In this case, okay, this is what I want to say. Indeed, swarm robotics is the science in study how we can program robot in a way that is similar to the swarm that we saw in nature. I don't know if you never saw a school of fish, that form this collective structure of birds in the, that fly together without collide with each other. This is the area that I try to target in my research. And, there is a lot of application. Okay, consider, we wanted to steer like a swarm of drone to, like Amazon, you want to bring the stuff to, home or for the home. And this we can use swarm robotics to this kind of stuff. Obviously, we can also do something magic like, fireworks. You saw that video of fireworks made by drones? Yeah. You say, oh, but it's useless. I know, but I like things that move together. Sorry, my fault. And, okay. Here the question that is a big question in research, how we can engineer such system. So how we can create application that perform this kind of behavior in a safe and modular way. This is really hard. We have no solution yet. We try to do that, but we have no solution. The inspiration comes from natural social animals, as I say, like school of fish, herds of sheep, I think, and group of bees. And then I start this, I start to research this kind of stuff because when I was, a child and I worked with my grandfather, I used to see this kind of, big flock of birds. I was like, wow, but this is amazing. And then here I am, 27 years later. Okay. Please, okay. There are a lot of challenges because in general we have no central authority. We cannot have a central server that coordinates the groups. We have the problem of energy because in general the robots are really small and we cannot perform our tasks there. We have the problem of locality. Each robot only perceives a small portion of the environment. Large scale, you saw the video, there are hundreds of robots. And then we have the problem of openness. We cannot know the number of nodes in advance. And also the problem of the emergence. This is not like the emergence we are used to talk about. It's the emergence like from bottom, so from local behavior, collectively emerge a structure. This is the problem of emergence. So there are, people try to do that. And in general, we have two macro areas. The one that are related with multi-agent reinforcement learning. So we try to learn how these collective structures are formed by doing, so giving a feedback to the group. Another way is called macro programming, in which we develop paradigms in which we program directly the collective. So there are like an abstraction that close the gap between the solution, so the idea of forming these groups and the programming language from a collective perspective. In my research group, we do both, and we do both in Scala. So because we are like, we hate each other, we really don't love ourselves, so we use Scala. I mean, Scala makes sense for this kind of part, because here, we can create the domain-specific language really easily. This kind of part was like my fault, so, but it's fun, so it's okay. For the first part, we implement this kind of paradigm that is called aggregate computing. The idea of this paradigm is to use as a collective structure stuff called computational field. You can show it like an electromagnetic field, the one, but in which in each point you have computational value. So you can have sensor, you can have movement, and in general the idea is that you have a topology, and you can see that like this, like a continuous field with stuff. On top of this, you can create a language, and then with that language you can create collective structure. This is the idea. Obviously, there is a lot of shit under, under the floor, but this is the idea. How many people do that? We are like this kind of group. We are only in Cesena, the city in which I work. We are like in 8. Not that much. Sorry. We are not like a company. We try to do our best. But as a research group, we are kind of three main research groups. One in Bologna, another one in Torino, and Ryan Tech is like a US company. And we developed some open source project that our first one written in Scala is ScaFi. The other one this is a simulator. This is another language. It is a toolkit for multi-agent reinforcement learning in Scala that use ScaFi. Just to give a little bit of taste what we program with ScaFi. This is the domain-specific language, so it's kind of high level. In this case, I write a program that links this zone to this zone, like to try to find a path. Each node can only see its neighborhood. So, for instance, this node can only communicate with this, and this. Stop. And the plan is to create like a path from here to here. These are obstacles, so we cannot go towards them. And the good part of the paradigm is not only that it creates this structure, but it's also self-healing. So if you change the structure, eventually it'll find another equilibrium. Like, the flock of drones. That if you go against another one, you see here, I move the destination to another part, and eventually this path will be reformed. Then I move the source here. After some point, another path will be formed. It needs some time, but eventually, you see. Do you like it? You like in general swarm robotics? This is what we love. Okay. On top of this, it's possible to create like libraries. This is one library that we use for program the swarm behavior. So the structure of the swarm. This code, for instance, produces this behavior like obstacle avoidance and drones that go towards the direction. And we can also write other code like this one that is flock around the center. This one form like shapes, and this one like branch the system in 2 parts. And any of these need a central coordinator. It's fully decentralized. Okay. Now, okay, this need hours to explain this one. Sorry, guys, but just to give some insight. Reinforcement learning is quite easy, okay? This is the art of improve a model by interaction with the environment. It's really similar of how human learns, When you are a child, you make some mistake, you slap, and then no, I don't want to do this again. If you receive a reward, you perform the same action more and more. how this, this environment, this framework can be extended to multi-agents. What does it mean? Consider a video game, you don't have only one agent, you have, a population of agents that you want to coordinate. So there is, I can conclude with this video, this is a wonderful video of OpenAI. Before they made ChatGPT and stuff, I really love them. They made this video in which they use multi-agent reinforcement learning to play hide and seek. And the fun part is that, there is emergent behavior in which, eventually the agent find good policy to block other agents. And the funny part is that, they play for like days, say weeks. But the funny part is that each agent know nothing about the environment. They just have a bunch of action, they perceive something, and they receive like, okay, you win, you lose, stop. Like after weeks, they learn really good strategy, like this one, you see? They block the other one. Ah, look, little bastard, aha, you cannot access. I mean, this is another reason why I start my research. If you wanna, we can share the slide, because there are a lot of video if then you wanna play at home. Okay, on top of this, what we did is, on top of this, please, I thought perhaps I should go to the end. Damn, I made bullshit. Okay. Now? Okay. No. Okay. Now this is on top of this framework. What we did, we implement this library that is called ScarLib. That means Scala Reinforcement Learning Library, something like this. I mean, one of my students developed it, so I didn't remember the true acronym of this. What is the idea of this library? Here there is a video in which we explain the main features, but the idea is that we particularly want to perform reinforcement learning in swarm robotics. That is a kind of a tough scenario. So we implement a bunch of algorithms that works on that in Scala. And this way we can integrate ScaFi, that is the framework that I showed before. This integration showed that you can beat the state-of-the-art algorithm in combining the aggregate computing part with multi-agent reinforcement learning. So it's really, hard to explain in details, but if you have questions or something, you can contact me here. If you like this kind of research, please contact me. And yes, it's over. I hope to don't bore you too much. And so, yes.